Okay, in this exercise session, we will finish number 41 and number 42. So this recitation session is for number 41 and 42. Number 41, consider a mixture of a buffer A, which is 0.1 molar in CH3COH, acetic acid, and 0.1 molar in CH3COO minus. Okay, so as soon as I see this, I know that the pH is equal to the pKa, which is equal to 4.75. Okay, they don't have the pKa given here. Okay, let's take it to be 4.75. Calculate the pH change. Pay attention, they want the pH change, not the pH. The pH change is basically final minus initial in each of the following cases. When we add 100 milliliters of A and 10 milliliters of HCl, that is 0.1 molar. Okay, good. So 100 milliliter of A is basically your buffer, which has a pH of 4.75. 10 milliliters of HCl will react with the base in the buffer. It's always important to know what species will react with which species. So in part A, for number 41, part A, we can simply just write the reaction. We have 100 milliliters of A plus 10 milliliters of HCl. You know that the active component is H3O+. A consists of the acetic acid and its conjugate base. HCl will react with the conjugate base. So the reaction will be CH3COO minus plus H3O plus to give you CH3COOH plus H2O. Always assume that it's complete with the strong species. Okay? So we do the ICE table very easily. You can do only IE, but I will do the change. CH3COO minus in A is basically 100 milliliters times the concentration, which is 0.1. This is 10 times 0.1, 100 times 0.1. You should now be aware that here I'm working with millimoles. So limiting is H3O plus, which is 1 millimole. All reactants will lose 1 millimole. All products will gain 1 millimole. You will get 9 millimole, an epsilon value or approximately 0, and 11 millimole. Now you have to change into concentrations. You already know this, that you have to divide by the total volume. However, I already know that I can just simply use Henderson-Hasselbalch. So I will not change into concentrations. I already know that I have CH3COO minus, CH3COOH, acetic acid, pKa is 4.75, CH3COO minus is 11 millimole. If you divide by the total volume above and below, the total volume will cancel, so it's okay. And this is 9 millimole. And the pH is now equal to, I think, 4.67. Okay? You can find the change, which is delta pH. It is basically 4.67 minus 4.75. Delta pH doesn't have to be negative or positive. Negative will only tell you it's going into the acidic region. Positive will tell you it's going into the basic region. That's it. And it's getting more acidic or more basic because this is already in the acidic region. This is already in the acidic region. Okay, that's part A. Part B. In part B, you have 100 milliliters of A again, but this time with NaOH. NaOH is HO minus. HO minus will react with the acid, not the base. So you start the reaction with acetic acid plus HO minus, CH3, COO minus plus H2O. Okay, so if the addition of H3O plus in part A decreases the pH, the addition of HO minus in part B will increase the pH. فاكروا فيها logically. Why? Because in part A, the acid is actually increasing to 11 millimole, من 10 ل 11 millimole, while the conjugate base is decreasing from 10 to 9 millimole. While in the second part, تذكروا initially 10 millimole. This is also, I think, 1 millimole, لأنه they added 0.1, 10 millimole. So in the second part, the acid at the end will decrease to 9 millimole. This will be an epsilon. And the base will increase to 11 millimole. So the pH will increase. So you have 4.75 plus log 11 divided by the acid, which is 9. Okay, I think هوني my bad قلبناهم شوي. It's 9 divided by 11. Okay, it's 9 divided by 11. The base is 9, the acid is 11. So 11 divided by 9, and this will approximately be around 4.8. And you can simply now find the delta pH. You will notice that the delta pH is actually exactly the same from above and below. Okay, the only difference is plus. So let's assume that the delta pH is around 0.1. Remember, check the accuracy of this number. It will be a little less than 0.1 because it's weak. Okay, and this is 0.1. Again, accuracy. If you add an acid like HCl, the acid will decrease the concentration of the conjugate base and increase the concentration of the acid. It means that the pH will decrease because now the acid is a little more predominant and delta pH will be negative. However, if you add a base, the base will consume some of the conjugate, some of the acid, and it will increase the value of the conjugate base, causing the base to be a little more predominant than the acid, and delta pH will actually be positive. So in fact, you don't need to calculate if it's, let's say, qualitative. If they ask for the addition of an acid, you can simply say that the pH will decrease. Addition of the base, it will increase, unless they want the actual value. And I think that's part B. Let's see what happens in part C. We add 100 milliliters of water and 10 milliliters of HCl 0.1. Conclude.